This is video number 4 for sections 4.4 and 4.5, application problems starting with the percent. So here's another scenario for us to consider. This one is about cable TV. It says the average number of cable channels per household was 135 in the year 2010 and has been growing by about 8% per year. Here's our let statement. Let C be the number of channels at time t years since 2010. So t is our independent variable and c is our dependent variable. The first question, what kind of function is this? Well, it is most definitely an exponential function. How do we know that? Because it is a situation that is growing at a constant percent. That's what we learned in the last problem. If you have a situation where your outputs are growing by the same percent over and over and over, in this case each year, it will always be an exponential function. Letter B goes on to say, now let's write an equation, and it seems to imply that this will be a very easy one. Well, the only way that it can be easy would be if somehow I know the values of A and B already, if that information is given to me. Well, remember, A is our y-intercept. The y-intercept is always some sort of starting value. So I go back up to my definitions. T is the number of years since 2010. 2010 is our starting year. If they told me something about 2010, I'll know the y-intercept. Well, here it is. That's the only data point that we were given. In the year 2010, there were 135 channels. That would correspond to the ordered pair 0, 135. T stands for number of years since 2010. C stands for number of channels. So I know that my A value is 135. As far as the B value, we may not know it directly at the moment, but we just about have it because of that great little formula B minus 1 equals R. If you know the R, remember R is the constant percent, you can quickly figure out the B. I'll just plug in B minus 1 equals my R in this problem, my constant percent is 8%. I need to write that as a decimal. That would be 0.08. Just solve this equation for B and you're done. Adding 1 to both sides, I get B equals 1.08. Well, now that I know my A and my B, I can quickly write down the equation of the function. I should use the correct letters. My dependent variable is C equals 135 times 1.08 to the T. That's the equation of this exponential function. The point of this example is if they hand you the constant percent, they are for all intents and purposes handing you the B. Well, let's continue. Now we're being asked to describe the C-intercept of our model. C is our y value, so that's essentially the same as the y-intercept. We already wrote that earlier as an ordered pair. That was 0, 135. And then if I want to explain the meaning of that, I just have to take into account both the 0 and the 135. Well, I might need to check my variable definitions. I'm reminded that T stands for number of years since 2010, and C is the number of channels. And so in this ordered pair, the 0 would mean 0 years since 2010, so in 2010. And the 135 would be 135 channels. So in 2010, there were 135 channels. All right, that takes us to letter D. Use your model to predict the average number of cable channels today. Well, today meaning 2017. Of course, I don't plug years directly into my model. In my model, the T stands for number of years since 2010. So if I want to talk about 2017, I'll have to use T equals 7. Let's copy our model down, and then I'll go ahead and plug 7 in for t. And then all that's left to do is reach for the calculator. I don't have any rounding instructions here. Since C stands for number of channels, it probably makes sense just to round it off to the nearest whole number. So let's reach for the calculator, and it looks like we get about 231 channels. That's our prediction for the average number of cable channels today. Finally, that takes us to letter E. Letter E says we're to use our model to predict when is it going to be that there will be an average of 500 channels in each household. Well, remember, we go to our model. These models can't do very much. This particular model, either you can plug in a T and figure out C, or the other way around. In this problem, we're being asked to plug in a number of channels, 500 channels in place of C, and then we need to solve for T. Well, here's where things get kind of interesting. We have never solved an equation with a variable up in the exponent position. In fact, we don't have any way of getting that t down on the main line. It's trapped up there. We're not going to figure out how to deal with that until we get to chapter 5. So as this note here indicates, the only way to answer this sort of question now is to use the intersect feature on our graphing calculator. Let me show you the setup, and then we'll go to the calculator. Basically, what I'm about to do is I'm going to take the left side of this equation and type it into the y1 line of the calculator, and I'm going to take the right side of the equation and type it in to the y2 line of the calculator. That will essentially create for me a system of equations, and I will use the intersect feature in order to find the solution. Alright, so I'm at the main screen of the calculator. I need to go to the y equals area. Looks like I've got some old stuff there that I need to clear out. I also need to make sure that my plots are off, and they are off. And as we just said, what we're going to do is in the y1 line, type the left side of the equation, which was just 500. And then in the y2 line, we'll type the right side. It was 135 times 1.08 to the, use the exponent button, x. And I'll arrow over to close my parentheses. Well, now I need a window. I could try Zoom Standard, but I don't think that's going to be a very good picture. After all, I have numbers in here like 135 and 500. So I'm thinking that I better go to the window and do some thinking about what I might want to see. Remember, X in this problem stands for years since 2010. I don't really need to go into the past, so I think I'm safe to start at 0. As far as an X max, I'm really not quite sure. I'm not sure how far in the future I need to go. I think we just did 2017 and there were around 200 channels, so I got to at least go as far as that. Why don't I go 30 years into the future? That may or may not be enough. So I'm going 0 to 30 on the X. I'll count by tens. The Y is a little bit easier. That's the channels. Well, obviously I don't have negative channels, so I'll start at 0. And as far as a maximum, I need to go at least up to 500. I think I'll go up to 600 just to make sure I can see everything clearly. And I think counting by 100s probably makes sense. And then let's take a look at the graph. If I can see the point of intersection, then I have what I need, and sure enough, here it is right here. Right? All we've really done is we've drawn our model, and we're just interested in knowing, well, what year is it, the years are down here, where we're going to be up to 500 channels. The blue line represents the 500 channels. If I can just find that intersection point, I'll have my answer. Well, remember, we go to the Calc menu, second Calc, and we choose Intersect. And then we just hit enter 3 times. So 1 and 2 and 3. And once the screen says intersection, we know we have it. Of course, we already knew the y was going to come out to be 500. That was the point. What we're interested in here is the x value. 17 approximately, rounded to the nearest whole year. That would mean 17 years since our starting year of 2010. So back to the handout, we got a t-value of about 17 from the graphing calculator, which means the final year that we'll give, 17 years plus 2010 would be 2027. For now, if you need to solve an equation where there is an unknown in the exponent position, you're going to have to use the graphing calculator and the intersect feature. There is no other way. Later in Chapter 5, we will learn the algebra that we need in order to solve this equation by hand.